Sklearnpreprocessing quantiletransform. Description: the quantile transform method in scikit-learn is a data preprocessing technique used to transform features to a uniform or a normal distribution. This transformation ensures that features have the same distribution, regardless of their original distribution. It's especially helpful when dealing with features with skewed distributions or outliers, which can negatively impact certain machine learning algorithms. Inputs: X. This is the input data, typically a NumPy array or pandas data frame. It represents the dataset you want to transform. Output distribution: this parameter specifies the desired output distribution. It can be uniform for a uniform distribution or normal for a normal distribution. Outputs: X_trans. This is the transformed data, having the specified output distribution uniform or normal. Steps: rank transformation. First, the quantile transform method ranks each feature in the input data X. This assigns a rank to each data point within each feature, indicating its relative position in the distribution. Distribution transformation. After ranking, the method transforms these ranks according to the specified output distribution uniform or normal. This means it maps the ranks to values that follow the chosen distribution. Metrics: distribution similarity. The success of the transformation can be evaluated by comparing distributions of the original features and the transformed features. This can be done visually with histograms or by using statistical tests like the Kolmogorov-Smirnov test. Model performance: the effect of the transformation on the performance of your machine learning model can be measured by comparing its performance on the original data with its performance on transformed data. Visualization plots: histograms of the original features and the transformed features can be plotted to visualize the distribution changes. Box plots can be used to show the central tendency and spread of data before and after the transformation. Fine-tune parameters: n quantiles. This parameter determines the number of quantiles used for ranking and transformation. A higher value can result in a more accurate representation of the original distribution, but it can also be computationally more expensive. Output distribution: this parameter, as mentioned earlier, allows you to choose between a uniform or a normal distribution for the transformed data. Copy: this parameter specifies whether the transformation should be applied to a copy of the data or to the original data. Setting it to true creates a copy, while false modifies the original data. Random state: this parameter is used for reproducibility, especially when using algorithms that rely on random sampling. Uncertainty methods: bootstrap resampling. This technique involves repeatedly drawing samples with replacement from original data to create multiple transformed datasets. The variation in the transformed data across these resamples can give you an idea of uncertainty in the transformation process. Cross-validation: this technique involves splitting the data into multiple folds and applying transformation to each fold separately. The difference in the transformed data across the folds can provide a measure of uncertainty. Challenges and fixes. Challenge 1. Description overfitting to the data. If the n quantiles parameter is set too high, the transformation can become too sensitive to the specific values in the training data. This can lead to overfitting, where the model performs well on the training data but poorly on new, unseen data. Sample use case: when transforming data for a fraud detection model, using a very high n quantiles might capture specific patterns in the training data that are not generalizable to real-world fraud cases, leading to poor performance on unseen data. Fixes: Lower the value of n quantiles to reduce sensitivity to the training data. Use cross-validation techniques to evaluate the model's performance on unseen data and adjust the n quantiles parameter accordingly. Challenge 2. Description handling of outliers. The quantile transform can be sensitive to outliers, as they can significantly influence the ranking and transformation process. This can distort the resulting distribution, leading to inaccurate transformation. Sample use case in a medical dataset with blood pressure readings. A single very high blood pressure value could significantly impact the transformation of the entire feature, leading to an inaccurate representation of the blood pressure distribution. Fixes. Remove outliers from the data before applying the transformation. Use a robust outlier detection method, like the IQR interquartile range method, to identify and remove outliers. Consider using a different preprocessing method, like standardization or normalization, that is less sensitive to outliers.